Hey guys, welcome back to Western Rick Weather. So today I will be analyzing the April 2nd high risk event. So today we're going to start with radar animation here with this convective line. You can see the high risk pointed out here. So you got some of these cells firing off here, making a line with for squall line tornadoes, high damaging wind gusts, hail, very big event. It was a very a lot of PDS tornado warnings were issued, and you can see some of the squall I kept on continuing. Some of these thunderstorms kept on initiating here in the moderate zone here. Some of these cells here are long tracked, had a nice environment to, you know, strengthen and mature into these stronger cells here. This is more of a broad radar scan of the whole event through until the 8th. It was the same storm system. It was a very vigorous trough that came down, very vigorous low pressure that kept on continuing. This is the 8th, where a slight risk here that is, potent, but still producing a lot of these thunderstorms here. If we go to SPC, so tonight we do have a enhanced risk. So why should we talk about this enhanced risk? Because we need to understand what these thunderstorm outlooks are. So we have 5 categories. We have a marginal risk where there's some chance of thunderstorms. There's a small marginal chance for these thunderstorms to create damaging wind gusts and severe hail. The confidence isn't there as we continue to get some of these enhanced, moderate, even high risk. The confidence is there. You think, oh, these storms will be powerful. These storms could damage stuff. A slight risk here. Usually, that's been issued usually 2 to 3 days before an event. If it depends on each event, we can see here on Thursday for our area, we do have a risk of slight risk here for Buffalo. An enhanced risk, this is more confident. I would say for the slight risk too, it's like a loaded gun scenario. There's no confidence on it. So if the confidence is there, so it would be enhanced. The slight is like a loaded gun scenario where if these conditional atmospheric conditions are met, it would be powerful enough to cause a severe storm, which is gust up to at least 58 miles per hour, a 1-inch hail, or a tornado. I might refer to significant severe, which is like a hatch risk. If we see here, a hatch risk is a shaded lines here, whereas wind gusts over 75 miles per hour, 2-inch hail, or a significant tornado would be EF2 or higher. The moderate risk are like high-end events. So is a high risk, obviously, but moderate risk, there's usually like a detail or two that's missing. Maybe you might have the thermals for. You got good cape, you got good updrafts, but you don't have the shear. That could be some of these storms could be significant. There's no marginal hatch risks, but there is a slight enhanced, moderate, and high risks. High risks are more rare. Lately, in the past few years, they used to do 1 or 2. This year has been an anomaly, you could say, where many have been issued. Very intense storms. high risk might be only issued once a year, but it's really rare for like places like in the Northeast because you got the Great Lakes like stabilizing the air. So a high risk in 1999 where there was a big tornado outbreak in Western New York. It was a more of like a derecho per se, but it has skull line tornadoes and all these, and like hail and some damaging wind gusts. So the SBC had issued a high risk for portions right, including Memphis, there's places south. It's not in the typical tornado alley places you think of Oklahoma, near Oklahoma City or near Dallas, in these areas. So for tornado, so you see this 2%. So they're saying there's a probability of a tornado within 1 point, within a 25 mile of a point. So say for instance, 2% plus the historical average does add up when it gets up some of these like 10, 15, even 30%. It's really likely to get a tornado in these higher risks. So you could see the significant severe. A lot of people call it SIG severe on, quick chats. So that's a hatch area. There's no 5% hatched. There's only a 10 hatch and above. These risks go up to 60%. And there's like a whole graphic you can put out to show what these hazards are and what the categories are. The wind here is more of a windbag event, whereas squall line tornadoes and just a squall line straight line wind gust damage. So that included Indianapolis, Columbus, Memphis, Nashville, St. Louis, and these in the 45%. This is a little bit higher than this tornado probability. This tornadoes like to form more southern to the line because you get more like inflow and outflow. The hail, there was a 30% hail, so you got bigger hail. It was a very broad area. They didn't put on the 45% here. See, we could see here. So along with multiple EF3 plus tornadoes were possible. In the day one convection at 21 Zulu here had really strong this lower level moisture will continue to spread throughout the day on a 50 to 70 knot. A knot is about 35% faster than a mile per hour. So that's like 80-ish miles per hour, which is really good for thunderstorm development because you don't want the thunderstorm to tower. Even though it looks cool, to make it more severe, you want these shears to get the thunderstorm going, get more energy. Where that's different in tropical weather, where you want the towering thunderstorms. So MU CAPE is convective available potential energy. That's like the energy to help start thunderstorms. So if you look at model runs here, you get some of these absurd 2,000, 3,000 joules per kilogram range. That's a very big factor in thunderstorm development and severe weather development even. Alright, if we continue here, so these convective outlooks come out daily, even within. There's one usually issued around 2 to 4 a.m. Eastern time. There's one usually around 1:30. Sometimes they come out earlier. It's very interesting. One tool I like to use is the Iowa State Mesonet. Even though it's for Iowa, it has the National Weather Service uses it. I do like let's see. I love the IEM Cow with storm based warnings. The Raccoon helps, it's very helpful for. I like to use it for its IEM Cow bot rather, not cow. If I can find it. So yeah. I'm gonna feature some articles that I found, as this was also a big tornado event. This also had flooding events too. Weather Prediction Center, I decided not to include it because flooding, even though you can see in this photo here, seems like it was a big deal. It wasn't the main threat that like tornadoes do cause. Also, flooding is not as appealing than to tornadoes. If we continue on this article, this also talks about the NOAA National Weather Service cuts that were proposed at the end of this historic event. Some of these darker greens go up to 12. There's many places that got up to 15 inches. Memphis, this is like a metro. 12 inches, this is pretty catastrophic to infrastructure. Flooding is not like places like in Memphis don't get this a lot of rain. Like places like Florida, especially down south near Keys, does get this rain. But this is really hard to have this rain on the infrastructure. Got lots of flooding. This standing water is really bad. River gouges are like how the National Weather Service issues flash flood warnings. If we, let's see, there's many, at any time there is flooding here. If I pull up radar, we do have a flash flood warning for, let's see, there's just Shreveport, LA National Weather Service. So they have automatic gouges to issue flash flood warnings. So this one has a considerable tag. So this is actually 2 to 3 inches already has fallen. And they're saying more in the warned area. You can see some of these heavier thunderstorms here. As this thunderstorm, there is this line that has been curving its way through. We still have these tornado watches up, and we still have some of these severe thunderstorm watches up. But that's not for this video. So we got some tornado damage here. So this is April 3rd at Lake City, Arkansas. So damage shows from a drone here. You could see a violent tornado has destroyed Lake City, or at least portions of it. See, damage indicator says EF3. In my opinion, some of these houses are slabbed, meaning the concrete is showing that's signs of EF4 damage. It's very destructive. You can see all the tree branches and bark is just gone. And this car has been lifted up and smacked down on a car, and it's a crazy scene. Some of these tornado damages. Um, yeah, more damage. This article shows. This has lots of information. Um, so, especially from the National Weather Service, we got some damage in the in rain. This shows lots about the rain aspects of it. It's pretty good for the person to understand. If we look at the SPC outlook, um, some of these words I don't even know. I sometimes I'm learning from the SPC, learning about these. Most of this I already know because I forecast. Um, you can see which you can see here the warm sector in advance of these storms is characterized by a boundary layer dew point in the low 60s, low to mid 60s, and near 70 Fahrenheit. And you got Arkansas, Louisiana, and Texas here, and Mississippi's included. So a lot of these wording's very complex to the normal reader. Sure, meteorologists and people who know these terms would understand, but a person who's just found this and wants to know about the severe weather threat, they might not know what CAPE is. ML CAPE. They don't know what some of these terminologies. Discrete's different. So on the National Weather Service, this is from Product Kentucky. Paducah. I can't speak today. So this shows the squall line we saw earlier, and all the rated EF tornadoes. I think most of these are preliminary. Most of these are EF2, EF1, EF0, EFU. I think there's some. I think most of these EF1s. There are some near Memphis here, EF3 here. Some of these EF3s could produce lots of damage. 165 peak winds. One home here has multiple walls collapse, and another has all the walls collapse onto a concrete slab. And this is damage indicator of a high EF3 or an EF4, depending on the person who's assessing the damage. They're saying around 160. I would say, if I remember correctly, yeah, Manitoba. I think that one's 7 EF4, but I'm not a meteorologist yet. Another 160 mile per hour one. You can see there's a trend of these storms over here just kept going. Long lived. See, this is a very long lived tornado here, this EF3. It's probably one of the highlights of the event about the tornado. If here, City Tornado, we saw the damage from that was the EF3 damage. You can see that outlines of the EF3 damage found. See, EF3s are severe tornado. There's a tornado calculator you could look at. So NBC News, it's a news station. This was on every single news station on the internet. We're saying there's already deaths reported, which is very sad. You can see some damage from on near in Oklahoma here. Pretty good damage to that roof. You got damage. You got flipped cars. I like this article because it talks about more. It's more understandable to the reader. Say, for instance, oh, you don't know what CAPE is? It talks about like the energy, and it talks about the political aspect, the government aspect. Kentucky Governor Andy Beshear declared a state of emergency for this 4-day severe weather event. They talked about SPC's high risk event. Got some lightning, lots of rain. The National Weather Service has a life-threatening, catastrophic, potential historical event. And questions come up. How should we prepare for severe weather? How should we predict it? Well, you can use models. So there's many models that forecasters like me use. So I have this website. This is Tropical Tidbits. There's also Pivotal Weather that a lot of severe weather forecasters use. So we have the GFS, or the Global Forecasting System. It's the Global Forecasting System. It's more of a long-range model. This goes out 300 hours. You don't trust some of this stuff. Yeah, there won't be a blizzard in Canada there in May 13th. But some of these shorter range, I like to have it around 200 as my sweet spot to use for forecasts. So we could tell what's coming April 30th. This is an old run. Oh no, it is constant. I don't know why it's... Oh, I'm reading it wrong. Oops. Okay, initiated. Okay, sorry. So at 12 Zulu, May 3rd, we could see some thunderstorms here. So there's many models. This is the numerous weather predictions through models. We can use math and supercomputers to predict the weather. So I like to use GFS. We got ECNWF, or the Euro model. Some of these models obviously have their faults, like CMC here, or the Canadian model, has a colder trend on everything. See snow here. Doesn't go as far out, 240 hours. I think ECNWF goes out 360. I was wrong, but you can see some of these model runs are more, this is moisture, frozen, and just regular precip. You can tell some of these heavier thunderstorms. You get heavier rain, thunderstorms. Indicators of severe weather. Thermodynamics, SP CAPE, and wind crossover. So you can see these capes. Say, this is later. This is about 72 hours ago. This was 3 days. So we can take a sounding here. There's the Pivotal Weather soundings I like better because it has more stuff, more about the wind profile. But we do have the Hundo graph here. You can see the curves to see if it's the storm motion. You see the graph here talking about temperature dew point, what's really in the air. You can see here, this has SP CAPE at 3,000. This is at 2,000. MU CAPE. So this is most unstable CAPE. There's different CAPEs. So most unstable is different energy sources, and we can use that to see if there's a severe weather event, and obviously there was. If we go back to precip, you can see some of these heavier thunderstorms. They have a few cells, glow line potentially here. So as we were talking about CAPE, how does CAPE affect thunderstorms? You might ask. CAPE is like the energy. As explained earlier, these thunderstorms produce heavy rains, and you try to shoot up. Sometimes there's a cap where the thunderstorms, there's like a cap where the thunderstorms can't go any higher, but sometimes the cap breaks. So these thunderstorms use this energy to get more like powerful. It's like the energy you need. Obviously, there's more than one thing in severe weather. Like you want good shear, you want good moisture, you want good dew points, all this good stuff. So, if we go back here onto the NBC website, I feel like depending on what you want, it's very subjective. You want something easy to read? Go with the NBC News. That's what it's for. That's why they wrote it. They want to make money from this, so they write a whole article about it. If you want something more scientifical, but you don't want something like the SPC's Outlook, if you don't understand that, this has more information about it. With more data points. This talks about the political aspect too. You can read the Yale Climate Connections article. The SPC, these outlooks are for emergency. They're not for the average reader. They're for the emergency managers and in counties. These are for mostly for the government, but these are always available on SPC's website. And these have very in depth about the tornado outbreak. I forgot to mention this also included stuff about flooding, which this also did say stuff about flooding, not as much. You could see if we, rain. Some about the rain. More about the rain here. 2 to 3 intense rainfall, 2 to 3 inches an hour, which is very intense. If we compare that to lake effect is about, say, take for instance, you have 20 inches of lake effect snow. It's about 1 inch of rain. So imagine having 40 inches of snow coming down in an hour. Obviously, it's not the same ratio, but it's usually the common ratio with lake effect. But it's insane how much rain the storm did. Some indicators, even for hurricane models there's different models. These are the global models. These are full complete runs. These are ensembles. These are more for like temperature, moisture, precipitation. We can see the moisture. You see all this red-ish stuff, brown even. It shows the dry air, and this green stuff is more moisture. Yeah, this is very interesting for there's some aspects of severe weather you might use this, but this is good for hurricanes. Hurricanes hate dry air, so they want more moisture to strengthen their bands. We can use hurricane models. There is no active storms. There's no hurricanes anywhere. You gotta invest in somewhere. It doesn't look interesting enough. You can see we can check the pressures. It's not there. There's with lots of stuff happening. This is unset. They have aircraft reconnaissance as stuff in the past few months. There's not as much aircraft reconnaissance, which does not help meteorologists to, provide all of this information. So we can use hurricane models to check hurricanes. Mesoscale. So you have 3 types of scale weather. You got synoptic weather, which is this stuff, these big lows, big high pressures. You got mesoscale. These are like, I hate using them, but like some of these smaller cells that we can say we want to go to the northeast here, or not. We can use NAM3K as a very not great model, but it's cool to show. You can see some of these. Whoa, that's interesting. Sorry. You can see these individual cells. These show this is for mesoscale. This is all mesoscale weather here. To use individual cells. Lake effect 2 is considered mesoscale. Then you get microscale, which is the wind, like winds off lakes or winds off oceans, like stream to wind. It's very smaller scale. If you have any questions, please comment down below, and have a good day.